Welcome to our lecture online. Now that we've seen some examples how to set up these maximization problems using Simplex method, we're now actually going to do a real problem. It's going to be what we call two-dimensional, or with two variables. There's only going to be two unknown. Later on, we're going to show you some more complicated ones, but let's start off with a two-variable type of problem. So in short, because if you write it out in text, it would take up a lot of room on the board, but in short, let's say that the factory is trying to produce two products, A and B, and it does so on two machines. Each product needs to be machined on both machines. And the profit made for producing one of A is $6 per unit, and for one of B is $8 per unit. And A requires 6 minutes of time on machine 1 and 5 minutes of time on machine 2. B requires 9 minutes on machine 1 and 4 minutes on machine 2. So what are the limitations? Well, machine 1 is only up and running for 10 hours per week because of the maintenance, and that would be about 600 minutes. And machine 2 is only available for 6 hours. Let's say per day, but per week that seems kind of odd. So let's just call it per day. Let's say this is production per day. So 10 hours per day for machine 1 and 2 hours per day for machine 2, because the rest of the time the machine is being cleaned and being maintained to make sure that we can continue this production basically almost indefinitely. And so the question that would be, how many of A and B should we produce to make the maximum profit under these circumstances and limitations? So again, the procedure is exactly the same, but let's go through it very systematically. So now we actually do have to define the variables. So let X equal the quantity of A, and let Y equal the quantity of B. Why don't we use A and B instead of X and Y? It's much better to come up with two new variables and define the variables in terms of X and Y rather than in the original, because that causes problems. And so simply say let X equal the quantity of Y produced, and let Y equal the quantity of B produced. So now we need to determine what's being maximized, and of course in this case what's being maximized is the profit. Like that. Next, we need to come up with an objective function. Well, the profit is such, since we make $6 per unit for A and $8 per unit for B, and X and Y are the quantities of A and quantities of B, we can then say that 6 times X plus 8 times Y would be the profit function. So if we make 1 unit of X, we make $6. 1 unit of Y, we made $8. One of each, we make $14, and so forth. So there's our objective function. Now we need to determine the constraints. So we can see here that we have a maximum of 10 hours or 600 minutes on machine 1 and 6 hours or 360 minutes on machine 2. And we require machine 1 for both A and B. We need 6 minutes for each A on machine 1 and 9 minutes on machine 1 for each unit of B, which means then that 6 times X, so 6 minutes, X the quantity of A, plus 9 minutes, Y be the quantity of B, must be less than or equal to the total number of minutes available in machine 1, and that would be 600 minutes. So you can see here that this really represents the constraint due to machine 1. We have 600 total minutes. Each unit of X requires 6 minutes, and each unit of Y requires 9 minutes. We do the same for machine 2. So 5 minutes and 4 minutes. So we have 5X plus 4Y would be less than or equal to the total number of minutes we have, which is 360 minutes. Okay, now we're going to take those inequalities and turn into equations using slack variables. So if it's less than 600, add a slack variable to make it equal to 600. So 6x plus 9y plus the slack variable 1, that equals 600. And here we get 5x plus 4y plus another slack variable that equals 360. So now we've turned our two inequalities into two equations. Also, we need to take our objective function, move the x and y terms to the left side, so we set it equal to 0. So we end up with a minus 6x minus 8y plus p is equal to 0. And now we take those three equations and put them in a simplex tableau, in an augmented matrix as we call it, so we can go ahead and try to solve the problem. So our augmented matrix will look like this. We'll have the variables x, y, s1, s2, p, profit, and then we'll have a constant, and we'll have 3 rows of this, 2 for the equations over there from the constraints, and 1 equation from the objective function. So now we plug in the coefficients of x, y, and the slack variables. So 6 9100, and that would equal 600. And the second row, we get 5, 4, 0, 1, 0, and 360. And then the coefficients from here, -6, -8, 0, 0, 1, and 0. And so, of course, the standard solution, or the basic solution, I shouldn't call it standard, basic solution, is to realize that whenever we have a column that doesn't have a 1 and zeros, those variables will go to 0. So in this case, x and y will be 0. S1 will be 600. Oop, that's S1. So S1 is equal to 600. S2 is equal to 360. And the profit is equal to 0. So 0 profit starting out, because we haven't done anything yet. If you don't produce any x and y, any a and b, we'll make 0 profit. All right, now we want to go ahead and find where we need to pivot. And again, we take the largest negative number, which is this. So we're going to pivot inside column 2. And now we need to do a ratio. So the ratio of this number divided by the number in the column we're trying to pivot. So we have 600 divided by 9, or 360 divided by 4. Now, which of those two is the smallest quantity? If you're not sure, you just go 600 divided by 9 equals, let me do it again, 600 divided by 9 equals, that would be 66.7. So let's write that ratio down. So this is 66.7 for the first row, and 360 divided by 4, that would be 90, right? That would be 90. So this is the smallest fraction, or the smallest ratio, which means we're going to pivot that number in that row. We're going to pivot this number right here. Since it's not a 1, we have to first turn it into a 1. So our first thing we're going to do here is take this row, divide the whole row by 9 to make this into a 1 so we can pivot about it. So row 1 is now going to be replaced by 1/9 of row 1. Simply divide row 1 by 9. So if we do that, we get the following matrix. Notice that row 2 and row 3 do not change. We get a 5, a 4, a 0, a 1, a 0, and a 360. And then here we get -6, -8, 0, 0, 1, and 0. And the first row, 6 divided by 9 is 2/3. 9 divided by 9 is 1. 1 divided by 9 is 1/9. That would still be a 0, 0, and 600 divided by 9 would be 200 divided by 3. 200 divided by 3. So I took 600 divided by 9, divided the top and bottom by 3. I get 200 divided by 3. Okay, so still x and y are still 0. My slag variable, well, I can no longer say that I have a valid value for slag variable because that's not a 1, but we're not going to worry about that right now. So what I want to do next is, since I'm going to pivot about this number right here, I want to turn this into a 0, and I want to turn this into a 0. And I do that as follows. I take the second row and replace it by the negative of this number, -4, times the row with the pivot, and add it to the second row. And I take the third row and replace that by the negative of that number, which is the +8, times the row with the pivot, and add it to the third row. When I do that, those two numbers will go to 0. Of course, I have to take care of everything else in those two rows as well. So when I do that, I get the following matrix. So let's come up here. And my first row will not have changed. That's 2/3. That's 1, 1/9. That will be 0, 0, and 200 divided by 3. Okay, now, second row. -4 times this added to that, that will give me a 0. So that was, of course, the objective here. But what about the rest? So -4 times this is -8/3 added to 5. -8/3 added to 5. Well, 5 is 15/3. -8 plus 15 is it's plus 7/3. So this should be 7/3. So let's do that real quick again. 5 is 15/3. -4 times 2 is -8. So -8 plus 15 is a positive 7/3. All right. -4 times 1/9 is -4/9 added to 0 is -4/9. Okay, this will still remain a 1 because -4 times 0 added to 1 is still 1, and this will remain a 0. Now, -4 times this added to 360. At this point, I would recommend a calculator. So -4 times 200 is -800 divided by 3. So 800 divided by 3, make that a minus. So it's -266.7. and add it to 360, plus 360, which is 93.3333. If I multiply times 3, I get 280 divided by 3. So this becomes 280 divided by 3. How did I do that? Again, I multiplied this number times -4 minus 800 over 3 and add it to 360. I get 280 divided by 3. Now I still have to take care of the third row right here. Again, this will go to 0 because 8 times 1 is 8. Added to -8 gives me 0. Now, 8 times 2/3 is 16/3 minus 6. Sometimes, again, you just want to grab a calculator. So 8 times 2 is 16/3. And add it to -6. And I get minus 2/3. So right away, I can see I'm not done yet because these numbers need to go to 0 before I can say I'm done. Okay, next we have 8 times 1/9 added to 0 is 8/9. 8 times 0 added to 0 is 0, and that remains 1. Now, 8 times 200 divided by 3, so that would be 1600 divided by 3, which is 533 1/3. So that would be 533 1/3. So there's a nice intermediate result. We can now see that one of our variables has now been determined. Now, of course, it may not change that, it may not stay that way, but at least we can see that we have some progress here. Notice that x is still a 0 because there's no 1 and 0s in that column, so x is still a 0. But y is now equal to 200 divided by 3. S1 is 0 now. S2 is equal to 280 divided by 3, and the profit is now 533 1/3. So our intermediate result tells us that if we produce 200 divided by 3, which is 66 2/3 units of y, and 0 units of x, we'll make a profit of $533 1/3. Okay, that's good, but since this is still negative, we're not done yet. We could probably make a little bit more profit. So let's go ahead now, and we're going to start pivoting about this column. And if we do the ratio, 200 divided by 3, so let me just write ratio here so you know what we're doing here. So we're going to find the ratio. And so we're going to take 200 divided by 3 divided by 2/3. So 200 divided by 3 and divided by 2/3, that's divided by 2 times 3 equals, we get 100. So the ratio of this number divided by this number is 100. And the ratio of this number divided by this, that would be 280 divided by 3, and divided by 7 times 3 equals, I get 40. Well, 40 is, of course, smaller than 100, which means I'm going to pivot about this column and this row. That means pivoting about that number right there. Now, of course, before I can eliminate the other numbers in the column, I need to turn into a 1, and I'm going to do that by taking the second row, R2, and replacing it by 3/7 R2. If I multiply this row by 3/7, this will become a 1. All right, let's go ahead and find the new matrix. The first row doesn't change. 2/3, 1, 1/9, 0, 0, and 200 divided by 3. The third row doesn't change. That will be minus 2/3, 0, 8/9, 0, 1, and 533 1/3. Now what about the second row? Well, this will now become a 1. This number is still a 0. Minus 4/9 times 3/7. Okay, that would be 12 over 63. Well, the 3 and the 9 cancel out, so here I get 3 over 7 multiplied times 4 over 9. That's a minus 4 over 9. And that becomes a 1, that becomes a 3. So I get minus 4 over 21. So minus 4 over 21. 3/7 times 1 is 3/7. 3/7 times 0 is still 0. 3/7 times 280 divided by 3. So we have 3/7 multiplied times 280 divided by 3. The 3's cancel out, and 28 divided by 7 is 4, so this becomes 40. All right, pretty good now. So the next thing to do is to use this as a pivot point to get rid of this, turn that into a 0, and turn that into a 0, so I can find a value for my first variable, which would be the variable x. To do that, I'm going to take the first row, R1, and replace it by the negative of that number, 2/3, times the row with the pivot, which is R2, and add it to R1. And I'm going to take the third row and replace it with the negative of that number, which is a positive 2/3, times the row with the pivot, which is R1, and adding it to the third row, which is R3. All right, now let's go ahead and do that and see what we end up with. I'm getting the feeling we're getting fairly close to the answer. So, coming over here and drawing my new augmented matrix. So we'll draw the line this way, we draw the line this way. Now which row does not change? Of course, the one with the pivot in it. That doesn't change, so let's leave it alone. So you get a 1, a 0, a minus 4/21, a 3/7, a 0, and a 40. What about the first row? When I multiply R2 by 2/3 and add it to R1, oh, it should be a negative 2/3, shouldn't it? I have a 2/3 here. Did I do that right? Oh, yes. That should be negative 2/3, right? I want to multiply times the negative of that number. So negative 2/3 times R2 added to that. Otherwise, it would not go to 0. Good thing I got that. So this should be, let me put it clear, that's a negative 2/3 times R2. That's negative 2/3 added to that will give me 0. Here, nothing will change. And negative 2/3 times this, wow, negative 2/3 times negative 4/21. That would be 8/61 plus 1/9. So that would be 8/61 plus, that would be 7/63. That would be 63. 7/63, that would be 15/63. All right, so this would become 15/63. 3/7 times 2/3, that would be 2/7. That's the negative, that would be minus 2/7. This would remain a 0. And negative 2/3 times 40. So 2 times 40 is 80 divided by 3. That's a negative. And add a 2 plus the quantity 200 divided by 3 equals 40. Aha. So this becomes 40 as well. So now we've done that first row. Now all we have to do is the last row. Now notice when I add 2/3 times this, added to this becomes 0. This remains at 0. 2/3 times this, that would be negative 8/63 plus, that would be 56. And negative 8, 56, that would be 48. That would be 48/63. And when it comes down to these numbers, since you realize that slack variables don't have any value anyway, even if you make a mistake here, it doesn't really matter because we don't care. Here, this will remain, will not remain at 0 because 2/3 times this will be 2/7. But again, you notice that the slack variables are no longer have a value. They're now gone to 0. This will still be a 1. And finally, we're going to multiply this number right here by 2/3 and add it to this. So 40 times 2 divided by 3, and add that to plus 533.3333 equals, and it looks like it's going to go to 560. And notice we no longer have any negative numbers here. They're just zeros, and that means we are done. Also, we know we're done because we know that x has a value, y has a value. The slack variables have both gone to 0, and that means we should have reached our maximum profit. So, result is we should build how many of x? 40. Oh, yeah, right here. We've got to go down to here, and tells us that's 40. So x is 40. Y is 40. S1 is 0. S2 is 0. And our profit is equal to 560. Quickly checking that. So, coming back up here, we said that the profit can be determined by taking 6 of x, and x is equal to 40, plus 8 of y, of 8 times y is equal to 40, which means $6 for each unit of x, $8 for each unit of y. So this is equal to 240 plus 320, which is equal to 560, which is the same number that I got up here. So it looks like we did okay. And by the way, in our previous series, we did the exact same problem in a graphical method. And so go back and take a look at it, and take a look at this, and see how you get the same results in both ways. Now, the graphical method is probably a little bit easier in this case than using the Simplex method, but the Simplex method is so much better when you have more than 2 variables, because at that point the graphical method becomes almost impossible. And so this is just for us to learn how to do the Simplex method so we can then later do more complicated problems using this technique. Here you can say, I like the graphical method better, but it won't help you when you get problems with more than 2 variables. This is how we do it with the Simplex method.